So today we're talking about lesson 7.4, which is the special products of binomials. There are a few patterns that will arise when we have a certain type of problem. So we're going to look at a bunch of different examples. So let's say we have x plus 7, and we're going to multiply it by x minus 7. So we learned in the last lesson how to actually distribute that and how to multiply. So I'm just going to go ahead and say, okay, x times x is x squared. X times negative 7 is negative 7x. 7 times x is positive 7x. 7 times negative 7 is negative 49. When I combine the like terms, I end up getting x squared. These cancel because they're opposites of each other. They add to 0, minus 49. So that's what that would multiply to. Let's try one more. So let's say we have 2x plus 5 and 2x minus 5, okay? 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is positive 10x. And 5 times negative 5 is negative 25. Again, we have opposites here that add to 0, so they cancel. And this will give us 4x squared minus 25. Okay? Let's try one more and see if you can figure out what the pattern is. Let's do b plus 10 and b minus 10. So b times b is b squared. B times negative 10 is negative 10b. 10 times b is positive 10b. 10 times negative 10 is negative 100. We have a pattern of that middle term canceling out. And my answer seems to only have the binomial, the squared term, and the constant term. There's no linear term, okay? So my question to you is, how can you go from, let's say, x minus 2 times x plus 2, okay? There's something similar with all these problems. So see how we have the exact same first term in all of these? And then we have almost the exact same second term, except for their opposites. So it's positive 5, negative 5, positive 7, negative 7, positive 10, negative 10, negative 2, positive 2. So when we have that setup, we're going to be able to find a pattern. And we can essentially say that those middle terms will always cancel. So then we can just go x times x is x squared, and negative 2 times positive 2 is negative 4. Okay. We're also going to have another type where instead of we have opposite signs, we're going to have the exact same sign. So let's say we have x plus 7 quantity squared. Well, that's the exact same as x plus 7 times x plus 7. So if I multiply those out, it's going to be very, very similar to this, except for instead of a negative 7, we're going to have positive 7, and then positive 49. So instead of these canceling, I have two of the same, and I get x squared plus 14x plus 49. Okay, let's try it again. So let's say we have a minus 5 quantity squared. Well, I have a minus 5 times a minus 5. So we get a squared minus 5a minus 5a, and then plus 25. Okay, so that's a squared. We have two of the same. So I'm essentially doubling each one. All right. So let's try one more, and then let's see if you can figure out the pattern. So let's try 2m plus 1 quantity squared. 2m plus 1, 2m plus 1. All right, so that's 4m squared plus 2m plus 2m plus 1. 4m squared plus 4m. Again, two of the exact same, plus 1. All right, so can you figure out the pattern? And can you go from x plus 10 quantity squared to the answer without each of these middle steps? So it looks like this very first term, if I square it, then I get that. So a squared is a squared. 2m squared is 4m squared. So I'm going to say that that's x squared, because that's what x squared would be. And then I can recognize that the last term, this 49, is 7 squared. Okay, this 25 is 5 squared. This 1 is 1 squared. And they're always positive, so I'm going to bet that the last one is going to be 10 squared. So that's 100, so plus 100. Now that middle term, I know that I have two of the same, so if I imagine multiplying that times that, well, it's the same as multiplying 1 times 2m, right? So if I do x times 10, then I have two 10x's, so 10x, and I have two of them, so I'm going to say I have 20x. Okay, that's the pattern. If you look in the book, they're going to give you a formula, but if in doubt, you can always expand it out, right? So just write two of them and distribute, and then figure it out. That's it for today. Let me know if you have any questions.